In probability, there are independent and dependent events. Independent events are events that do not impact each other. So to tell if something is an independent event, you have to think about, if I do this event, will it affect the outcome of the other event. So keywords can be tossing a coin, rolling a dice, spinning a spinner, and not a replacing. So when you toss a coin, if you toss a heads, when you toss it again, just because you tossed a heads doesn't mean you're going to not have a heads. When you're rolling a dice, if you roll a 6 and then you roll again, the probability is still the same, so it's not affecting it. Same with the spinner and replacing. So to calculate independent events, you do the probability of the first event times the probability of the second event. So we'll do a couple examples here. You toss a coin twice. Find the probability of getting 2 heads. Well, these are independent events. So what you're going to do is you're going to find the probability that you get heads and multiply it by the probability you get heads. So the probability of getting heads is 1/2. So you multiply 1/2 times 1/2. So it's 1/4. Second example, you roll a number cube, a dice, once, then you roll it again. What is the probability that you get a 2 on the first roll and a number greater than 4 on the second roll? So a number greater than 4 would be rolling a 5 or a 6. So what you're going to do is you're going to find the probability you get a 2 times the probability you get a 5 or a 6. So the probability you get a 2 on a dice is 1/6. And then you multiply it by, there are 2 5 or 6s on a dice, so you multiply it by 2/6, or 1/3. So this is going to be, you can reduce your fraction, so 1/3. So you do 1 times 1 is 1, 6 times 3 is 18 is your answer. And this third one we're going to skip because it talks about a standard deck of playing cards. So you have to know playing cards, and I think some people might not know it. Okay, so a dependent event is when one event does impact the other event. The key word is do not replace. So here's an example of one. Suppose that you have 3 red sticks and 2 orange sticks. And I write, what's the probability of getting 2 reds and you don't replace? So to calculate this, you would do what's the probability of event A times the probability of event B after A has happened. So looking at this example right here, what's the probability of getting 2 reds is the probability of red times the probability of a red after you take a red out. So the probability of a red is 3 out of 5. Then we're going to take a red out and not replace it. So now so pretend that this red is gone Now the probability of a red is 1/2. So the answer is 3/10. Let's do it down here, an example. 3 girls and 2 boys, so 5 total, volunteer to represent their class at a school assembly. The teacher selects one name and then another name from a bag containing the 5 students' names. So this is when you're taking out a name but you're not replacing it. What is the probability both representatives will be girls? So you do what's the probability there's a girl time what's the probability there's a girl after a girl's been taken out. So I'm going to draw this up. I have 3 girls, 1, 2, 3, and 2 boys. So this is a lot like the last one. So what's the probability you have a girl is 3/5 times, now one of these girls is gone, what's the probability that you pick a girl again? So it's 1/2. So again it's 3/10. Let's do B. What is the probability that the teacher chooses a boy than a girl? So I'm going to write out girl, 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 boy, boy. So it's going to be probability of a boy, which is 2/5. Cross off the boy. Then what's the probability of a girl? Which is 3/4. So now you multiply straight across. 2 times 3 is 6. 5 times 4 is 20, which makes 3/10 again. What is the probability that teacher chooses a girl then a boy? So girl, 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 boy, boy. So you do what's the probability to choose a girl, which is 3/5. Then a girl is gone, and a boy is going to be 1/2. So it's the same answer, 3/10. After you reduce it, or 3/20, sorry. 10. Okay, are the events described below independent or dependent? Explain. A guest at a party takes a sandwich from a tray. Second guest takes a sandwich. So when you take the sandwich, you're not replacing it. You're eating the sandwich. So this is not replacing, so this is dependent. Sam flips a coin and gets heads. He flips again and gets tails. This is independent. Remember tossing a coin, rolling a dice, spinning a spinner, those are all independent. Alright. A shelf holds 3 novels, 2 biographies, and 1 history book. One student chooses a book at random, replaces it, and then another student chooses a book. So you're putting the book back. So I'm going to set up 3 novels. Novel, 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 biography, biography, history. So what's the probability there's both novels? So that's the probability that you get a novel and you get a novel again after you put it back. So it's going to be novels, there's 3/6 or 1/2 times 1/2, which is 1/4. What's the probability both are biographies? So the probability it's a biography is 2/6 or 1/3. And then 1/3 again. So it's 1/9 because you're putting it back. What's the probability it's a history, which is 1/6, then a novel, so it's 1/2. So 1/12. What's the probability they're both history books? So the probability it's a history book is 1/6, then you put it back and grab it again, so it's 1/6, so it's 1 out of 36. 2 puppies are chosen at random from a box at the mall. What is the probability of each outcome? So this time, you're not putting the puppy back, you're taking the puppy. So this is a dependent So the fractions are going to go down. So what's the probability? So first, there are 12 dogs. So what's the probability they're both black? So it's 4 out of 12, so it's 1/3. Then I'll write these out. So you have a retriever. Oops, you could have a black. I'll cross this out. You could have a black black retriever and black settler. So there's 8 total black dogs. So it's going to be 8/12. I'll reduce it later. But then you take out one of the black dogs. So there's only 7 black dogs left. And now there's 11 dogs because you took it out. So I'm going to, before I multiply, I'm going to reduce. So 8/12 reduces to 2/3. And now I'm going to multiply. So it's going to be 14 out of 33. So what's the probability they're both brown? So there's 3 brown dogs out of 12. But then you take a brown dog out, so there's only 2 left out of 11. And now I'm going to reduce. 3/12 reduces to 1/4. So I multiply and I get 2/44. What's the probability you get a setter, then a hound? So the probability you get a setter is 4 out of 12. There's 1 less dog, so there's 11, and there's 3 hounds left. So I'm going to reduce this to 1/3, and then the 3's will cancel out, so I get 1/11. What's the probability you get a retriever, then a setter? So it's 5/12 times a setter. So there's 4 setters left, but remember there's only 11 dogs because you took one out. I'm going to reduce 4/12 to be 1/3, and then I'm going to multiply. So it's 5/33.